We're given an inverse trig function, and one of the things we know is that the answer to every single inverse trig function is an angle measure. So the first thing you want to do is define that. So I'm using theta, and I'm just going to say theta is equal to cosine inverse of 2/3, which is what's inside the set of parentheses. Then if I take the cosine of both sides, that's going to undo cosine inverse. And so I end up with the cosine of theta is equal to 2/3. Okay, next I'm going to take this piece of information and build a triangle on the bow tie. So remember those triangles on the bow tie. There's like this little imaginary bow tie right here. So you're going to use one of those. And for cosine inverse, remember, is, for me, we refer to those as an OEO function. So it's either in quadrant 1 or in quadrant 2. And if cosine is going to be the angle measure that has an x coordinate of 2/3, the only quadrant between 1 and 2 where you have a positive x coordinate would be quadrant 1. So we want to build this triangle on the bow tie in quadrant 1. Okay, so then next, and frankly for all the inverse trig functions, if the fraction is positive, you're going to build in quadrant 1, because quadrant 1 is where all of the inverse trig functions are positive. Okay, so then next I'm going to use SOHCAHTOA to help me fill out part of this triangle. And cosine is adjacent over hypotenuse. So the adjacent side here is 2, the hypotenuse is 3, and we're missing the opposite side. I can use the Pythagorean theorem to find that this is the square root of 5. I'm not going to take a lot of time going through that. 2 squared plus an unknown squared equals 3 squared. Solve that equation, you get the square root of 5. Now that I have my triangle completely built, then remember we just called the cosine inverse of 2/3 theta. So the problem really is saying what is the tangent of theta? We've built a triangle to answer that question, and tangent is opposite over adjacent. So it's going to be the square root of 5 over 2, and that's our final answer. Okay, now when this fraction here is negative, it takes a little bit more thought. But once again, what's inside of the parentheses is an inverse trig function, and every inverse trig function is an angle measure. So I have a trig, make a triangle. So trig, triangle. I'm going to refer to what's inside parentheses as theta. So then I'm going to get rid of sine inverse by taking the sine of both sides. So I have the sine of theta is equal to -3/5. And we're going to figure out where we should build this triangle on the bow tie. For me, we're like inverse trig functions. For sine, it's a SAM-I-AM function, so that means that it's going to be in quadrants 1 or 4. Sine inverse is positive in quadrant 1, and sine inverse is negative in quadrant 4. So I'm going to build this in quadrant 4, maybe restating that again in layman's terms is that if sine is a y-coordinate and my only options for inverse sine is quadrants 1 and 4, then quadrant 4 is where the y-coordinate is negative. Okay, but my shortcut is that I call that our SAM-I-AM or OEO. All right, now SOHCAHTOA, this is opposite over hypotenuse. So I'm going to put these numbers in. Another quick reminder, because this fraction is negative, you might not realize if you should make the 3 negative or the 5 negative, but every time you're on one of these triangles, the hypotenuse is always a positive number. So if this is a positive number, I'm gonna have to make the 3 be the number that's negative. It's also directional. This is right, so this number is positive. This is down, so this number is negative. And the radius, which is what your hypotenuse really is always positive. Okay, so using Pythagorean theorem, I'm taking -3 squared plus unknown squared equals 5 squared, and I come up with 4. One more time, it's positive 4, because when you solve the when you solve the Pythagorean theorem, you get plus or minus 4, but because this is right, it's positive 4. Now that I have my triangle built, I can find the cosine of theta. I'm just going to emphasize that we called what's inside there theta, and the cosine of theta is adjacent over hypotenuse, so that's going to be 5 over 4, and we have that solution.